Greetings, we are a joint research team from National Taiwan University Academia Sinica and National Taiwan University Hospital. Today we're going to introduce our study, Effect of Progressively Available Features in the Clinical Timeline on Predicting 3 Days Readmission in an Emergency Department with Machine Learning Methods. In this video, we'll go through our work from defining the research problem of predicting readmission, explaining why predicting readmission is important and how did previous studies do about it. Then we are going to share details of materials and methods, including our database, features, machine learning models and further importance analysis. After that, we'll show you our results and findings based on those results, then give you some conclusions and suggestions. First of all, we need to know why is readmission so important. Readmissions to a hospital are usually taken as an indicator of medical services qualities of that hospital. Because if some patients didn't receive the proper medical aids, the medical needs are still being unmet. Then those patients may readmit to the hospital for the same or worse healthy issues. So the best way to deal with a readmission is to prevent it by giving a good care of patients while they're still in the hospital. However, is it better to keep the patient in hospital as longer as possible? Of course no, that'll cause wastes of time, medical resources and overcrowding issues. But letting the patient discharge too early causes the readmissions and those issues as well. That is why predicting readmission is so important that many studies are working on it. And readmissions in emergency department within a short period of time are more critical because the medical needs are usually more urgent. That's why we focused on the readmission in emergency department. Now let's see what previous studies did about readmissions. Many studies tried to predicting readmissions with various methods, including designed medical indices and machine learning methods. They predicted readmission in order to evaluate the health status of patients. Also, they want to provide a clinical decision support system for doctors to make such decision, should I let this patient discharge like this? However, the performances of previous studies are usually not good enough for the practical usages, because there are too many factors would lead to a readmission, including clinical and non-clinical ones. And even if they do achieve an acceptable predicting performance, the results can't be easily compared with others due to the differences between each private database. Another issue is, most of previous studies apply all the features stored in the database, which is all the available features right before or even after the discharge. We consider that as a limit to a practical clinical decision support system, and we'll explain it in the next slide. If we want to apply such support system in a practical scenario, we should consider a special characteristics of these clinical features. These features are being accumulated to the database after the corresponding clinical procedures are done. In other words, we can make the prediction earlier with lesser features to help doctors to know the situation of patients earlier, instead of doing it until their discharges. As you can see, as time goes later and later, more and more features are available for us to predict the readmission. But, obviously, using lesser features cause less accurate predictions. Therefore we need to find out how these features affect the predicting performance. Again, in this study, we want to analyze the relationship between available features and the predicting performance. So we first use as much as possible features, robust machine learning methods and a huge amount of clinical data to create a performance baseline, in order to do the further ablation studies and importance analysis. We used Shapley value, a game theory-based method, to identify the importance of individual features. Then we analyzed the importance of features from different clinical procedures, time points, and their categories. By doing so, we found out a trend of the relationship between performance and the earlier usage. Then we give suggestions for the users of this kind of clinical decision support system based on our results. A total of 543,610 all-cause ED admissions between 2012 to 2016 in the National Taiwan University Hospital in Taipei were collected in this study, including 24,224 records of readmission. A readmission is defined as a patient admits to the ED within 72 hours after his/her discharge last time, which often implies a more urgent situation than one after a longer period. For ease of denotation, we simply use readmission to represent such events hereafter. The detailed demographic composition of recruited patients and admissions show in the right table. Patients of all ages admitted for medical services were included, except the admissions only require issuing diagnosis certificates without any treatment. We also filtered out some data before 2013 to compute the number of visits in the last year, which is an important feature used by previous studies. Total 1302 features were extracted from the National Taiwan University Hospital Integrated Medical Database, which were retrieved from the Hospital Information System. These features are composed of 8 types of medical records: administrative information, demographics, triage records, vital sign, chief complaints, ICD codes, examinations, and some temporal information. When we needed to combine raw data from multiple datasheets, we took patient-specific ID and admission-specific account ID to retrieve the correspondences. As a patient experiences different clinical procedures, corresponding medical records are saved in the HIS simultaneously. Therefore, we can split the features into 5 groups according to the sources of these features, that is, the clinical procedures, admission, triage, diagnosis, treatments and examinations, and finally ready for discharge. To deal with a tabular-style medical dataset where each feature is meaningful and less multi-scale spatial correlation, the gradient boosting decision tree-based methods usually perform better than the pure deep learning methods and linear regression. Besides, we can also utilize the interpretability of these tree-based model for the feature contribution analysis. 4 tree-based machine learning methods were adopted in this study, including CatBoost, LightGBM, XGBoost, and Random Forest, which are popular tree-based machine learning models for various tasks and contests. We split all samples into training and validation sets with a ratio of 8:2. The hyperparameters of 4 models had been selected by the grid searching method. Then we finally report the validation performance of models with 5 metrics, that is precision, recall, accuracy, F1 score, and area under the receiver operating characteristic curve. In order to discover the effects of different groups of features on the prediction of readmission, we analyzed the importance of features with the Shapley values, which is often applied for the interpretability of machine learning models and mining of the valuable features for clinical prediction tasks as well. We analyzed the importance of features according to different clinical procedures and feature types with the corresponding contribution of the total absolute Shapley values calculated from the trained model with the best AUC performance. Prediction performances of models with all features. The performances of boosting models were close to each other, but better than Random Forest while all features are available. Although the precision seems quite low, it is reasonable for the extremely imbalanced dataset of readmission with only 4.5% positive samples. On the other hand, relatively not discriminative recall and F1 score indicate that all-caused readmission is challenging to predict, even when the patient is ready for discharge. Among these 4 models, CatBoost has the best AUC performance. Therefore, we took as the representative model trained with all features for the following feature importance analysis. Prediction performance with accumulated features. No surprise, the performance of the prediction increased with accumulating amount of features during the clinical procedures. Compared to changing the learning algorithm, add more features will get more improvement. It is worth to note that the performances of models are already close to 0.67 with merely 66 features just right after patient's admission procedure to ED. Which means we can achieve a basic performance in the earliest point in the timeline with only these initial features. From the result, we found features that were collected during triage and close to discharge are significantly much more helpful for the models to predict readmissions. It may imply that the information acquired in these 2 phases are more abundant and useful for the prediction, which might be attributed to the amount of features or some features that are more decisive. In contrast, ICD codes chosen during initial diagnosis and examination results are less useful, but the performance were still slightly enhanced with them. Importance of different categories of features. From this figure, we can easily find out that which kind of features are important to the model. Surprisingly, the administrative features, which are not correlated to patient's illness, contribute to the prediction most. And such result agrees with a previous study by Harlan et al. Published in 2016. These administrative features contain information about how and when patients arrive to emergency department, short-term and long-term medical resource utilization, and whether outpatient services are recently unavailable due to the holidays after discharge. Therefore, we strongly suggest those non-clinical features should be also considered while predicting readmission events in the future studies. On the other hand, the measured vital sign during triage and final diagnosis ICD, which directly reflect patient's initial condition and conclude diagnosis, made minimal contributions. The result may imply that the initial status do not directly lead to a readmission event. And the relative smaller impact of ICD code may be explained by fact that the medical cares and clinical services are much more important than a simple classification of diseases. As we can see, the second comparable important category is the temporal characteristics of vital signs, which comprise general variables used in descriptive statistics, such as min, max, mean, slope, sample number, etc. These temporal features represent multiple observation results and trend of patient's condition, usually toward stable. Features of this category usually give clinical physicians more confidence to decide on discharge. Such results are telling us whether patients have a stable health records may lead to different follow-up events after their discharges. We also found that the chief complaints and examinations are almost equally important. Chief complaints is extracted from text records and structural features utilized by a 5-level Taiwan triage and acuity scale computerized system, mainly containing patients' subjective statements and nurses' descriptions of their complaints. Examinations contains 55 lab test results, including chemical and physiological indices and the blood culture report. It is known that these results also affect the decisions of discharge in clinical practice. Actually, while looking at these diagrams, we can have a sense that the subjective description from patients and objective testing results are both important for the prediction. Let's conclude what we found in this figure. According to the results, it is suggested that future studies should not only focus on those clinical-related features, such as vital sign temporal observations and lab test results, but also aware of those non-clinical features and subjective complaints to achieve better prediction of patients' readmission. Let's move on to this figure, importance of features at different time points. Please note that these numbers are categorized by the time point, which means the features are only available in that certain time point. So there's actually difference between the ratios of the last diagram. Another thing you need to know is there's no diagnosis bar here, even they had been through that procedure. The reason is the model we used was trained with the ICD codes in discharge phase, not initial ones in the diagnosis phase, so there's no original ICD code from diagnosis anymore, and showing contribution in this time point is not available. Surprisingly, features gathered from admission contribute most among 4 time points, including patient demographics and most of the administrative features. Such results actually give us a notion that we could have a basic predicting performance in such earlier stage in emergency departments. The higher contribution of these features may credit to the high importance of those non-clinical, administrative features gathered while admission. As a second clinical procedure, the triage time point also provides an informative contribution to the prediction. The features including here are mainly initial vital signs and some triage records. You know what, from our experiences, patients usually receive the first diagnosis less than 1 hour after their admissions. And you may have discovered that the summation of contributions of admission and triage is already over 50% of the importance. This finding guarantees a balanced prediction between the performance and an early prediction. For the later 2 clinical time points, we still have another 45% of importance. Examinations results and temporal observation are also essential and could further improve prediction performance. So, if you prefer a more accurate prediction, use them all. Please note that the proportions of contributions from different time points here also reflect the model performance increment shown in the previous line chart. Since the total contribution of late features from examination to discharge also close to half, clinicians should be aware of a trade-off between the prediction performance and the early usage. With such results, we suggest that the practical clinical decision support systems should be able to make the early prediction with only admission and triage data so that the medical care and resources could be distributed more reasonably. In this study, we had investigated the effects of incremental characteristics of medical data on the prediction of readmission. By utilizing the huge amount of medical records, we are able to extract total 1302 features for the prediction. With machine learning methods and a thorough feature importance analysis, we can conclude our works in these 3 points. First, the most important features come from the admission stage in an ED visit, as well as the temporal trends of the vital sign before discharge. Second, the readmission is not only related to the clinical factors but also related to some non-clinical factors. And these non-clinical features are even more important than other features. So future studies should assess those non-clinical factors carefully before excluding them. Finally, the users and developers of such clinical decision support systems for evaluating readmissions should carefully consider the progressively incremental characteristics for the trade-off between early evaluations and the performance of such clinical decision support systems. Thanks for watching, and we are glad to take any further questions.